Welcome to Math TV with Professor V. In this video, we're going to learn how to perform division with polynomials. In previous video lectures, we've gone over addition, subtraction, and multiplication with polynomials. So now that leaves division to be considered next. And first, we're just going to look at the most basic example of division when you have a monomial divided by a monomial. What do I mean by that? When you just have one term in the numerator divided by another term in the denominator. And basically, this division here, right, is done using the rules of exponents. So that's how we're going to simplify the variables. And then you perform division the regular way when you have those constants in the front. So 15 divided by 3, that would give us 5. And then to simplify, we have x to the 6th in the numerator, x to the 4th in the denominator. So you just subtract those exponents, 6 minus 4, always numerator minus denominator. That's going to give us x to the 2nd, or x squared. And then we have y squared in the numerator and y to the 1st in the denominator. Remember, we don't have to write that 1. It's assumed if there's nothing there. So 2 minus 1, that gives us y to the 1st. So I'll just write y. Okay, good. So this is the foundation. Now we're going to build on this. So what if we had more than one term in the top? So we don't have a monomial anymore in the top, but we still have a monomial in the denominator. So something that looks like this here. If you had a plus b, or a minus b, it doesn't matter, divided by c. Well, what you would do is just go term by term in the numerator, dividing by c. So you would take a divided by c, and then keep whatever sign is between the terms in the numerator. So I'm going to write plus b divided by c. Okay, so let's practice applying this principle now to some of the following examples. So first one here, divide. We have 50x to the 4th minus 30x cubed plus 20x divided by 10x cubed. Okay, so first I'm going to start off by writing 10x cubed under each of the terms in the numerator separately. So I have 50x to the 4th over 10x cubed. Then I'm going to put minus. Why minus? Because there's subtraction right here. So keep the same sign. 30x cubed over 10x cubed plus 20x over 10x cubed. All right, now to finish off the problem, we're just going to simplify each of the terms or perform the division like we did earlier. So 50 divided by 10, that's just 5. And then now subtract the exponents for simplifying x. So we have x to the 4th over x cubed. 4 minus 3, that's 1. So we just have x to the 1st. Minus 30 divided by 10, that's just 3. And then x cubed in the numerator, x cubed in the denominator. 3 minus 3 is 0. So x to the 0 would be 1, or these just cancel entirely, however you want to think about it. Plus, and then this is where it gets interesting. So 20 divided by 10, that's 2. Now notice in the numerator, we have x to the 1st and x cubed in the denominator. So the power of x is larger in the denominator. You could write it as 1 minus 3, which would give you negative 2, right? You always do numerator minus denominator. But typically at this point in your math career, you don't want to leave negative exponents in your final answer. So instead, the way we're going to write that is x squared, but in the denominator. So if you want to think of a quicker way of kind of getting there, you still subtract the exponents, right? 3 minus 1, wherever it's larger, that's where you end up writing the result. So 3 minus 1 is 2. There were more powers of x in the denominator, so I'm going to put x squared downstairs in the denominator. If it was x cubed up top and x to the 1st in the bottom, then you would have x squared left over in the numerator. Okay, so that's our first example done. Let's box it. And because you had that denominator left over, this is technically a remainder, right? Because everything didn't divide in evenly. All right, let's look at another example here. This time we've got all these negatives running around the paper, so stay focused. We've got negative 12p to the 5th minus 8p to the 4th minus 6p cubed plus 5p squared over negative 3p cubed. So I'm going to write out everything separately over the denominator, which is negative 3p cubed. So take some time, do this carefully, and we'll address all the negatives and how to deal with the signs in just a second, okay? When you get a little bit more comfortable, you may not need to write out each of the terms separately like this. You might be able to just divide in your head, and that's totally fine. Just check with your instructor if they want you to show every little step or not. Okay, negative 12 divided by negative 3 is going to give us a positive 4. And then p to the 5th over p cubed, that's going to give us p squared, right? You do 5 minus 3, which is 2. Nice. Now be careful with this next term. See how we have a negative and another negative in the denominator? Those two are going to cancel and give us a positive. 8 over 3, that's not going to reduce or divide evenly. So just leave it like that, okay? 8 over 3. And then p to the 4th over p cubed, that's going to simplify to p to the 1st. And to make it really clear, since their power was bigger in the numerator, right, I'm going to write p to the 1st in the numerator. You don't have to put the 1, but that's where it goes. Okay, next term, again, these two negatives cancel. So we're going to have plus 6 divided by 3, that's 2. And then the p's are totally gone, right? They cancel out. Bam, bam. And then the last one here, check this out. Positive, negative, that's going to make this a minus. 5 over 3 doesn't reduce any further. And then again, 2 minus 3, that's negative 1. I don't want to leave a negative exponent in my final answer. Since the power on p was larger in the denominator, I'm just going to put p to the 1st in the denominator. Leave it there after you subtract. Okay, so we've got 5 over 3p. And that's that. Okay, how are you guys feeling? So we looked at how to divide a monomial by a monomial, a polynomial, more than one term, by a monomial. Now we're going to look at what if we're not dividing by a monomial anymore. So what if down here we have more than one term? What do we do? Well, in that case, we have to use long division. And maybe it's been a minute since you did any long division, right? You probably did it last in like elementary school. Who knows? So we're just going to review how we perform long division first, because there's 4 basic steps. And these same steps apply to polynomial long division. You probably are on autopilot now, though, when you long divide. You don't even realize what the 4 steps are. So say I gave you something to divide, like 14 into 389, okay? The 4 steps are as follows. First, you divide, meaning you divide 38 by 14. 14 won't go into 3, so you move on to the next digit, right? So 38 divided by 14, how many times can 14 go into 38? Just twice. And we put that result up top. Then the second step is that you multiply. You multiply whatever you just wrote up top by the divisor. What the heck is the divisor? This guy right here sitting outside. Whatever you're dividing by, that's the divisor. So you multiply 2 and 14, which gives us 28. That 28 goes underneath what you're dividing into, the dividend. Then step 3, do you know what step 3 is? Yes, we subtract. Okay, so we're going to subtract 28 from 38, which gives us 10. And then the fourth step is you bring down the next digit, and when we do polynomials, it'll be bringing down the next term. So you're going to bring down the 9. And then you repeat the process again until you can no longer keep repeating. So now we're going to divide 14 into 109. So how many times does 14 go into 109? It's 7. Okay. And then you multiply. So 7 times 14, that's going to be 98. Step 3, we subtract. 109 minus 98 is 11. And then in this case, there's nothing to bring down, right? So we've exhausted that. Also, we can't divide anymore because this number is smaller than the divisor. So we're done. And then maybe you'll remember this. This is our remainder. And the way you would write your answer is that you have 27, and then your remainder is 11 over 14. And this is kind of poor notation that we've adopted, but really what this means is that you have 27 plus 11 over 14 remaining, okay? So sometimes you'll write, depending, 27, remainder 11, but in that case, you don't know what the divisor was, right? Which can be a problem. Okay, so these 4 steps we're going to apply right now for the polynomial long division. I'm going to write them off to the side to help us. If you don't need it, that's cool. Okay, you want to get to a place where you can do polynomial long division on autopilot too, but sometimes it takes some practice. Okay, so let's look at our first example here, divide. Example A, 2y plus 1, that's our divisor, is going to be divided into 12y squared plus 20y plus 7. So I'm going to write out the 4 steps here, just like we did for the first long division problem. And the first step is divide, right? Okay, don't get overwhelmed. When you divide polynomials, that first step, divide, means only divide the leading term of the dividend by the divisor. These names, I know, they're a lot to handle. All you got to remember is you're just taking 12y squared, the leading term, and dividing it by 2y. Don't look at all the other terms that come afterward, just the leading terms. So 12y squared divided by 2y, that's 6y. And that I'm going to write up top, 6y. Another way you could think about it, some students like doing it this way. What do I need to multiply 2y by to make it 12y squared? That's doing the same thing. The answer is 6y. Okay? Step 1 is done. Step 2 is we multiply. What do you multiply? You multiply the result from step 1 by the divisor, which is 2y plus 1. So you're going to multiply 6y by the divisor, which is sitting outside. Okay, so we're going to distribute 6y times 2y, that's 12y squared. And then 6y times 1, that's 6y. Where do I write this? Underneath the dividend. So right here, I'm going to have 12y squared plus 6y. Very good. Now step 3, we subtract. Okay, so I usually put a minus sign here and parentheses, but you're going to have to remember that that minus sign distributes to everything inside those parentheses. So 12y squared minus 12y squared, that cancels out. The term on the farthest left should always cancel out. If for some reason these don't cancel, then you messed up in a previous step, okay? And then we have 20y, don't forget this minus sign's distributing, so 20y minus 6y, and that gives us 14y. And then step 4, we bring down the next term. In this case, that's a plus 7. Okay, good. Then we repeat the process because we're not done. So round 2, divide. What do I divide? Don't get overwhelmed. You're just dividing 14y by 2y, just the leading terms. So 14y divided by 2y, that gives me 7. You could also think to yourself, what do I have to multiply 2y by to make it 14y? Same thing. Since it's a positive 7, I'm going to put plus 7 up here. And then step 2, we multiply. Okay, what do I multiply? The result from step 1 by the entire divisor. So 7 times 2y plus 1. Or you could think of it like this. Distribute, distribute. If you don't want to do all this work off to the side. Okay? So this is going to give us 14y plus 7. This goes underneath. And then now, step 3, we subtract. Boom, boom. And everything cancels out, not just the term on the furthest left. The 7 cancels out also, and we're left with 0. There's nothing to bring down, so step 4 doesn't apply. And our remainder is 0. So what does that mean? That actually means that 2y plus 1 is a factor of the dividend. So I'll show you what I mean. Your final answer, the quotient, is sitting up here, 6y plus 7. So I'll rewrite that down here, 6y plus 7, and box it. And I want you to notice something about division, okay? I already wrote this setup at the start of the problem to be performed using long division. But another way we could have written it is 12y squared plus 20y plus 7 over 2y plus 1, right? And since we had no remainder, what that means is that 2y plus 1 is actually a factor of the numerator, of the dividend. So we were actually very lucky this time. So that means we can actually factor 12y squared plus 20y plus 7 into 2y plus 1 times, let's think, I'm just going to do it backwards here. If this is 12y squared, 2y needs to get multiplied by 6y, right, to give me 12y squared. And then 7 comes from 1 times 7, so this must be a plus 7. Let's check if that works when we FOIL. That's 14y. That's 6y. Ding, 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 that's my 20y. Okay, and then here's 2y plus 1. Cancel, cancel, 6y plus 7. And you might say, oh my goodness, that's so much easier. Why did we do long division? Well, 2 reasons. 1, we were told to. And 2, we were fortunate in this case because 2y was a factor of the numerator. What if this didn't factor at all, or it didn't factor in a way that we could cancel out the denominator? Then you would have to use long division, okay? So if you notice something factors, go for it, but if not, then you do still need to use long division. And you'll have a remainder. Let's look at an example now, because I'm sure you're super curious. So example B is written the way I wrote the previous problem, the second way. So we have 2r cubed minus 5r squared minus 6r plus 15 over r minus 3. So I'm going to rewrite it. So we're set up to do polynomial long division. R minus 3 out here divided into 2r cubed minus 5r squared minus 6r plus 15. Okay, I'll write out the steps for this one and then maybe no more. So step 1, we divide. Remember, you're just going to divide the leading terms. So 2r cubed divided by r. And that's going to give us 2r squared. I write that up top. You can also ask yourself, some students like this better, what do I have to multiply r by to make it 2r cubed? It's 2r squared. Okay, step 2, we multiply whatever we got from step 1 by the entire divisor, which is r minus 3. So this distributes, and we're going to get 2r cubed minus 6r squared. That result goes underneath the dividend right here. Do you remember what step 3 was? Good, subtract. So put your parentheses. If you don't trust yourself to remember to put parentheses and distribute the negative, you could just change the sign of all the terms that you're subtracting and then just add together. So that cancels. And then negative 5r squared plus 6r squared just gives us 1r squared. And then in step 4, we bring down the next term. In this case, make sure you bring down that negative in front of the 6r. Okay, good. Now we're going to repeat the process again. So let me clean up a little bit. We're going to go through steps 1 through 4 once more. Okay, so step 1, round 2, we divide. What are we dividing? Remember, don't get overwhelmed. Divide just the leading term, r squared, by r. Or you could think to yourself, what do I multiply r by to make it r squared? Answer is r, so that's positive. That's going to go up top. Step 2, we multiply. So I'm going to multiply r, the result from step 1, by r minus 3, the divisor. And this gives me r squared minus 3r. Where do I write that? Good. Underneath, right here, r squared minus 3r. Step 3, we subtract. If you want, you can just change the signs on each of the terms that you're subtracting if it helps you remember to distribute the negative better. Negative 6r plus 3r is negative 3r. And then one more round for bring down the next term, which in this case is a positive 15. Okay, can we keep dividing? Yes, one more round. Okay, I'll write out the third round here. So divide. What do we divide? Don't get overwhelmed. Just look at the leading term. Negative 3r divided by r right here. Okay. Or what do you multiply r by to make it negative 3r? Negative 3. So that goes up here. Step 2, multiply. So when you multiply, you take the result from step 1, multiplied by the divisor, the stuff sitting outside, and that's going to be negative 3r plus 9. That goes underneath right here, negative 3r plus 9. Step 3, subtract. Okay, I'm just going to change the signs, see if you like that. These cancel, so 15 minus 9, that's going to be 6. And then there's nothing else to bring down, so step 4 doesn't apply. Okay, I cannot keep dividing anymore because notice this is a constant, which is a lower degree, right, than my divisor. I have r to the first and I have no r's left over here. So this is my remainder actually. Oh no, we have a remainder. Don't fret. So the way you write your final answer is you write the quotient up top. So 2r squared plus r minus 3 plus you take the remainder and you write it over the divisor, just like you did with integers. So 6 over r minus 3. And that is your final answer. Okay. Now I did want to mention for this example, you could also use synthetic division. And I'm not going to really give you a list of steps to follow for synthetic division. I'm just going to do it right now. Watch and you'll see the pattern. It works out great. So for synthetic division, remember the original problem was, let me rewrite it here, 2r cubed minus 5r squared minus 6r plus 15 over r minus 3. So this is the divisor. You set the divisor equal to 0, and whatever value you get, that goes in a little box on the top left. That's where I like to put it. There's different ways of doing this depending on where you're from, but this is the way I like to do it. Just the solution, okay? Then you're going to list the coefficients of the dividend of the numerator, or what you're dividing into, in the same row. So we've got 2, -5, -6, and 15. So far, so good? Okay, leave a blank row and then draw a line. And here's the process. You bring down the first entry on the left below the horizontal line. So don't do a thing to it. Whatever it is, rewrite it. Now the pattern is as follows. You multiply on the diagonal. So 3 gets multiplied by 2, and you write the result in the next column. That's 6. Then you're going to add vertically. So -5 plus 6, that gives me +1. Then we multiply on the diagonal. So 3 times 1, that gives me 3, and that goes in the next column. You add vertically, so -6 plus 3, that's -3. Multiply on the diagonal, 3 times -3, that's -9. And then add vertically, that's 6. This last number here, that's your remainder. And then these 3 numbers here are the coefficients of your quotient. 2 for the 2r squared, 1 for the 1r, and the -3, that's a constant. How do you know what power to start with? Well, if you had r cubed and you're dividing by r to the first, then this is always going to be 1 degree lower. So this is 2r squared plus 1r minus 3, that's my constant, plus 6 over r minus 3. So this is synthetic division. Now, you still need to know how to do polynomial long division for a couple reasons. 1, if your divisor is higher than degree 1, meaning you had a r squared in the denominator, or r cubed, or r to the 4th, synthetic does not work. Synthetic only works when the divisor is linear. Also, if you're trying to find, say, the equation of an oblique asymptote, you still have to do long division. Synthetic won't always give you the right answer. If you're stressed about that later, we can have another conversation. Okay, but for the most part, it's a nice little quick shortcut. Just check with your teacher. If they want to see that you can do the long division, then do the long division. We must be obedient math students. That's how it works. Okay, let's look at another one. We'll do this one both ways. We'll do old-fashioned long division first and then synthetic. Okay, so we've got x plus 2, that's my divisor, that's going to go out here. And then I want you to notice something about the dividend. X cubed plus 4 minus x, that's not in descending powers. Plus, we're missing somebody. We're missing x squared. We need to put a placeholder. So I put a plus 0x squared. Some teachers just leave a blank spot. Do whatever works for you. Okay? I'm not going to write the 4 steps out. Let's see if we've graduated. So step 1, divide. X cubed divided by x. Or just think to yourself, what do I have to multiply x by to make it x cubed? Did you say x squared? Bravo. Okay, step 2, multiply. So you're going to multiply x squared by x plus 2. That's going to give me x cubed plus 2x squared. Step 3, subtract. So I'm just going to change the signs here, add everybody together. The term on the far left cancels as it should, and then I have 0x squared minus 2x squared. So that's going to give me minus 2x squared. And then step 4, bring down the next term, which is minus x. Now we repeat the process. So step 1, divide. Divide negative 2x squared by x. Or what do I multiply x by to make it negative 2x squared? What is it? Yep, negative 2x. Next step, you multiply. So you're going to distribute negative 2x to x plus 2. So this is going to be negative 2x squared minus 4x. Step 3, subtract. I'm just going to change the signs here, add everybody together. My 2x squared and negative 2x squared cancels, and then negative x plus 4x gives us 3x. And then step 4, bring down the next term, plus. Can we keep going? Yeah, 3x divides by x. Basically just check if the exponent here on the variable isn't less than the one that you're dividing by, you can keep going. So is there something you can multiply x by to make it 3x? You bet, it's 3, positive 3. And then now I'm going to multiply 3 times x plus 2. That gives me 3x plus 6. Then we subtract. 3x cancels. 4 minus 6 is 2. Nothing to bring down. Can't keep dividing. Oh, 4 minus 6 is negative 2. My goodness. Okay. So how do we write our answer? Well, we have x squared minus 2x plus 3. You see how our remainder is negative? So I'm going to write minus 2 over x plus 2. Good? Lovely. Okay, this one we could also find or divide by using synthetic division because the divisor is linear, right? X to the first, no higher powers than that. So let's try. Remember, you just set the divisor equal to 0. So x plus 2 equal to 0 means x equals negative 2. And that's the number that goes in the little box here on the left, okay? And then you list out the coefficients of the dividend. It has to be in descending powers and put a 0 for the placeholder again. So we've got 1 for x cubed. There's no x squared, so 0. Negative 1 for x, and 4 is our constant. Okay, let's see if you remember the process. Just bring down the first entry on the far left. Don't do a thing to it. Then you multiply on the diagonal. So negative 2 times 1, negative 2. Add vertically, so that's negative 2. Multiply, so negative 2 times negative 2, that gives me 4. Negative 1 plus 4, that's 3. Multiply negative 2 times 3, that's 6. Negative 6. Why do I keep doing that? And then 4 minus 6 is negative 2. So this is the remainder. And then here's the coefficients for the quotient. So we've got x squared. How do I know it was squared? Because this was the coefficient for x cubed. So when you do synthetic, your quotient's always going to be 1 degree lower. X squared minus 2x plus 3 minus 2 over x plus 2 again. Okay, lovely. How do we feel? Good? Okay, cool. Now the next one, I actually want to change it just a smidge. Okay. Instead of dividing by x minus 2, let's divide by x squared minus 2 because I want you to see something. First of all, now that I've changed it to x squared, you cannot do synthetic division. You have to do long division with this. The other thing is we're going to need to add a placeholder in the divisor as well. So x squared, I need to put a 0x and then minus 2. And this gets divided into 3x cubed minus 2x squared plus 5x plus 4. Okay? Good. So now we're going to run through the 4 steps. Step 1, divide. 3x cubed divided by x squared, or just think, what do I multiply x squared by to make it 3x cubed? The answer is 3x. Okay, So now we're going to multiply 3x by all the terms in the divisor. So 3x times x squared, that's 3x cubed. 3x times 0x, I put 0x squared just so that I have all my like terms stacked vertically. And then 3x times -2, -6x. Step 3, subtract. So I'm just going to change all the signs, add everybody together. So furthest term on the left cancels as it should. Then -2x squared and 0x squared is -2x squared. And then 5x plus 6x is plus 11x. Remember what step 4 is? Yes, bring down the next term, so plus 4, and then repeat the process again. Can we repeat? Is there something we can multiply x squared by to make it -2x squared? Yeah. The answer would be, or the result would be, that we're doing step 1, -2. And then now step 2, we multiply, so distribute that -2 through. So -2 times x squared, that's -2x squared, 0x, and positive 4. -2 times -2. Okay, step 3, subtract, so change the signs on everybody. And furthest term on the left cancels. I have 11x, and then 4 and -4 cancels out. Okay, so this is my remainder here. Why do I say that? Well, notice this term is degree 1. I have x to the first, and my divisor is degree 2 because of the x squared. So what I'm left with here is a lower degree. I can't keep dividing. So here's our remainder. So how would you write your result? It's 3x minus 2 plus 11x over the divisor. I'm going to put x squared minus 2. Don't put the placeholder when you write your final answer. Okay? And that is it. So that concludes the video. Give it a thumbs up if you found it helpful. Subscribe if you haven't already. And stay tuned. We're going to work through more intermediate algebra soon.